All right, now we're going to be starting a unit on functions, and our first section here, our first topic here, will be studying linear functions in the context of patterns. And the way we're going to do it in this video is first we're going to start out with an example. I'll give you after that a little bit of an introduction to what a function is, and then we'll do a second example. Okay? So for this first example, what we're going to look at is just this picture pattern that you see on the screen here with the trees. And these are often, when we look at patterns and linear functions, you can look at how things change based on the steps. So you can call this step 1, step 2, and step 3, for example. And that's going to be our independent variable, the step number. And the dependent variable here is going to be the number of trees. So the independent variable is going to be the variable that changes on its own. It just keeps on going from 1 to 2 to 3. And the dependent variable is going to be the variable that changes in response to what the independent variable is doing. So we have step 1, 2, 3, 4, etc. And we can just simply write down how many trees we see. We have 3, and then 5, and then 8. And I always like to actually include a row for step 0 if there were some sort of imaginary step 0 that we could consider here. And we could certainly keep going past step 3 as well to 4 and beyond. I hope what you're seeing here is that this is not going to be an 8, right? This is a 7. I made a mistake there, but that's okay. And I think you can see that we are adding 2 trees each time. So I think you can predict the future. This would be to 9, to 11, to 13, etc. And we can also work backwards. What would step 0 be? Step 0 would have 1 tree. All right, so that's an example of a table to describe that function. We can also graph the function as well. And often one of the hardest parts of a graph is setting up your scale. And so I would think about the two axes separately. Okay, so what do you want the x-axis to start at and go to? It's easiest to have it start at 0, and we can go every other square can be up by 1 step. And this we're going to label as step number. Looks like our y-axis we need to get up to about 13 or 15 or so. And we could go every square is equal to 1, but I'll just label every other. So I'll be labeling by 2s just to make things a little bit easier here. And this is going to represent number of trees. As a quick reminder, you probably know this already, but the dependent variable is going to go on the y-axis. On the vertical axis, that's the number of trees, and the independent variable is going to go on the x-axis. That's the step number. And we can just plot our points. At step 0, we have 1 tree. At step 1, we have 3 trees. At step 2, we have 5. 3, we have 7. And I really hope you can see why we call this a linear pattern right now. Because if we were to graph the points, as we just did, they fall in a straight line. Okay, so that is a linear pattern representing that function. A quick introduction to what a function is in general, and we will definitely get a lot more formal and kind of picky with what a function is down the road. But for now, I want you to just think of a function as a rule that transforms the input data, the x, into output data, y. Okay, so for the steps in the trees problem we were just looking at, is there a rule that takes the input variable, the step number, and transforms it into the number of trees? So if we have the step number, could we feed it into this function rule, and could that function rule almost act as a little machine and convert the numbers and spit out the number of trees? And the benefit of a rule is to think about, what if we wanted to know how many trees there were on step number 100? We wouldn't want to just continue the table down 100 rows. We'd want to be able to use an equation. Okay, so for this section, for this topic, we really just think of a function as a function rule, as a way of changing an input number into an output number. Another quick example, although let me actually say though first, we actually, in this video, we won't do any work on finding that rule. We will do that in a subsequent video. I just want you to think of a function now as a transformation from an input variable into an output variable. Let's look at another quick example, and it looks like we don't have much context here, but it looks like we're tracking days and maybe money that we've earned perhaps, or money that we've saved. I don't quite know. It looks like there are definitely some gaps in the table. And if we didn't know it was a linear function, we wouldn't really be able to fill in the table. But we do know it is a linear function. That's implied up here. And it looks like we're losing $5 each day. Okay, so maybe it's not money we earn, maybe it's money we have in our bank account on a day-to-day basis. So we can continue that pattern and predict that we would have had $37 on day 0, $22 on day 3, and then $12 on day 5. Okay, and the way we were able to do that is because we knew it was a linear function and we knew the change had to be the same with between each day. All right, so let's go ahead and graph this up, and looks like we have a similar x-axis to what we had before. We just need to go out to 5 or so. And we need to get up to 37. I might go up by, let's see here. This looks like it could be 10. Every 4 could be 10. See if that works. All right. Okay, so we can go ahead and label our axes. So this is the day, and this is our dollar amount. And on day 0, we had $37. And I'm going to show you a trick right here. If you just need to plot the line, you're not being asked to plot the individual points. As a quick tip, let's just plot the first and the last points. We know it's a linear equation, or we know it's a linear function, so we know the points are all going to fall on a line. So let's plot the first and the last. Pull out a ruler. I have my virtual ruler here, and we can fill in the points like so. Okay. Now, if we did need to plot individual points, we would need to go ahead and add the dots as well. I'll just add a couple. Okay. So that's an example of that linear function tracking the dollars in my bank account. Maybe you can predict when I'll reach 0, when I'll run out of money. All right, and it looks like, yep, that's a good place to stop right there.